Welcome to part 2 of the review video. I want you guys to review the 4 steps of the problem-solving strategy for any questions that require calculations. Not everything will include calculations. Let's begin with question 13. Which body is in equilibrium? Okay. When an object is in equilibrium, it can be in either two states: at rest or constant velocity. And the only choice that fits into that is choice D. Question 14 gives us a net force of 10 newtons for the first scenario. F net 1 is equal to 10 newtons with an object that accelerates at a rate of 5 meters per second squared. So we're going to take that same object. But first, what is the mass of that object? We're going to use the equation F net equals ma. 10 newtons equals m times 5 meters per second squared. The mass is 2 kilograms. So we're going to apply a new force to this same mass to accelerate it at a rate of 1 meter per second squared. So A2 is 1 meter per second squared, and we got to figure out the new net force. Using the same equation, same mass, F net equals ma, where F net is equal to 2 kilograms times 1 meter per second squared. The new net force is just 2 newtons. Choice B. Question 15 gives us a diagram of a 4 kilogram block and a applied force of 8 newtons. So we're looking for the magnitude of the block's acceleration. This is another simple F net equals ma equation. .0 newtons is equal to 4 kilograms times our acceleration. 8 divided by 4 gives us an acceleration of 2 meters per second squared. Choice B. Once again. Question 16 is an example of Newton's third law, where we have action-reaction pairs of forces. When there's an interaction between a pair of forces, like say the hammer and the nail, the forces are equal and opposite in direction. So the magnitude of the force the nail exerts on the hammer during contact is the same. The two forces between the hammer and the nail are the same. Question 17 asks for the weight of a 2 kilogram object on the surface of Earth. So the weight equation we're going to use is Fg, which stands for weight, is equal to mass times g. The weight is what we're looking for. The mass of the object is 2 kilograms. And the value of g on Earth, please note that it's different on different surfaces, is going to be 9.8 meters per second squared, where Fg is going to equal 19.6 newtons. Therefore, the answer is choice D. Question 18 is a bit of a trick question here, so be careful. A 2 kilogram object weighs 19.6 newtons on Earth. If the acceleration due to gravity on Mars is 3.71 meters per second squared, what is the object's mass on Mars? So what we should know is that mass never changes depending wherever you are. Mass never changes. Let's stress that with some underline there. So if the mass of the object is 2 kilograms on Earth, it should stay 2 kilograms on Mars. Choice B. Let's turn the page to question 19. So we have a 25 kilogram space probe falling freely with an acceleration of 2 meters per second squared just before it landed on a distant planet. So what is the weight of this space probe on that planet? Okay. The weight equation is Fg equals mass times g. We're looking for the weight. Our mass is 25 kilograms. And the g we're given here on this new planet is 2 meters per second squared. Please note this is not 9.8 because we are on a different planet than Earth. Multiplying those two together gets you 50 newtons. The answer is choice C. Question 20. So we have a 50 newton applied force to keep a 500 newton weighing object moving at a constant velocity. So what we have here is an equilibrium object because it's moving at a constant velocity. Constant V means the object's in equilibrium. When it's in equilibrium, our F net is equal to 0 newtons. And it's asking us for the magnitude of the frictional force acting on the object. So let's draw a free body diagram here. If we have a 50 newton applied force, and if our forces are balanced here, that means the force of friction here must also equal 50 newtons. The answer is choice C. A 0.5 kilogram puck sliding on a horizontal shuffleboard court is slowed to a rest by a frictional force of 1.2 newtons. What is the coefficient of kinetic friction between the puck and the surface of the shuffleboard court? Okay. Force of friction equation is F of F is equal to mu times F of N, the normal force. We're given a 0.5 kilogram puck. That will help us find the normal force. The normal force, we typically equate it to the weight of the object because the normal force supports the weight. So mass times g, the mass is 0.5 kilograms, and our g, we're assuming we're still on Earth, is 9.8 meters per second squared. And so our normal force is equal to 4.9 newtons. We're going to sub this back into our force of friction equation. The force of friction we're given is 1.2 newtons. We're looking for the coefficient of friction, mu. Our normal force is 4.9 newtons. Calculate that. The mu should equal choice A, 0.24. There's no units because mu is just a coefficient. Question 22, we need to find the magnitude of the force needed to keep a 60 newton rubber block moving across level, dry asphalt in a straight line at a constant speed of 2 meters per second. This is a little bit more involved. So let's draw a free body diagram. Okay. We have here that it's moving at a straight line of constant speed of 2 meters per second. When it's in 2 meters per second, constant speed, our F net is equal to 0 newtons. That means the applied force here is going to equal the force of friction. So we're going to have to look for the force of friction here. They gave us the weight of the rubber block, 60 newtons. That's already the normal force. And we got to use our reagents reference table to find out what's the coefficient of friction for a dry asphalt. So if we look in the table, dry asphalt has a coefficient of 0.67, whereas the normal force is the same as the weight, 60 newtons. 0.67 times 60 newtons is equal to 40 newtons, choice A. Okay, so questions 23 and 24 is an example of a short response question. 23 asks for the magnitude of the normal force exerted by the snow on the skis as the skier glides across the horizontal surface. In the prompt above, they gave us the weight of the student and the skis, which is 850 newtons. The weight is the same as the normal force. So therefore, the answer is just 850 newtons. Now, question 24 is a two-parter. we got to show our calculation work and get the correct answer. Doing both of those will give us 2 points. Okay. So we got to calculate the magnitude of the force of friction acting on the skis across the snow-covered horizontal surface. Our equation is f of f is equal to mu times f of n. From question 23, we established that our f of n is the same as the weight, which is 850 newtons. Our mu, we have to look at our Regents reference table on the first page on the table on the bottom right corner, approximate coefficients of friction. You looked for the wax ski on snow. Since the skis are moving across the surface, we look at the kinetic coefficient of friction, which is 0.05. So when we plug that all in, the frictional force is equal to 0.05